In this video, we'll be deriving the formula for orbital period. Now, shh, I have to be quiet because my family's still sleeping. So I can't be as loud in this video, but I'll try my best to still do this within a reasonable volume. So orbital period. What is orbital period? Well, you have a planet and you have an orbit. And maybe there's orbits of some satellite represented by yellow. The time it takes to go all the way around and then back to the starting point is the orbital period. An orbital period is usually represented by a capital T rather than a lowercase t. Lowercase t just stands for general time in seconds, but capital T usually stands for orbital period. So how do you calculate orbital period? First things first, Newton's universal law of gravitation always comes back to bite you. So this is Newton's law of universal gravitation, G big M little m over r squared. And big M stands for the mass of the planet that you're orbiting, and little m just stands for the mass of the thing orbiting. So this is little m, mass of little m, and this is mass of big M. It's pretty self-explanatory. Big M stands for a bigger object, little m stands for a littler object, or less massive object. So here's the thing, you can set centripetal force equal to the universal law of gravitation. The universal law of gravitation describes force, so you can set centripetal force equal to your universal law of gravitation, since both of them represent the same forces. Now you can cancel out m, and you can cancel out the exponent here and the r down here. So you get left off with the formula gm over r is equal to v squared. Well, you can square root both sides, so gm over r square rooted is equal to velocity. Alright, now we have velocity. We need to extract a formula that contains big T, the orbital period. So how do you do that? Well, let's go ahead and use some logic. Well, the circumference of a circle is determined by 2 pi r, correct? And velocity is distance over time. Well, if you have the distance of a circumference, 2 pi r, and you divide it by some time, wouldn't that time be your orbital period? So the time it takes to travel the entire way of the circumference, which is your distance in the velocity case, divided by orbital period, is equal to your velocity, or your orbital velocity. So this right here stands for distance, the numerator, and this right here stands for time, and distance over time is velocity. So we can actually set that equal to this guy right here. So now that we have velocities, we can actually set them equal to each other. So if we set them equal to each other, we get gm over r is equal to 2 pi r over t. Now all we have to do is isolate our orbital period. So in order to isolate that, let's create more space. In order to isolate that, we just need to multiply t and then divide this on both sides. So with just a little bit of algebraic manipulation, you get 2 pi r over the square root of gm over r. Well, just to simplify this further, you get t 2 pi r over gm over the square root of gm times the square root of r. Okay, what do you do next? Well, technically r is the square root of some square. So just a singular r to the power of 1 is the square root of r squared. Well, you can actually add these two together. So you get 2 pi, not add them together, you can multiply these two radicals together to get the square root of r cubed over the square root of gm. If you want to simplify this further, you should get, okay, we're running out of space, you should get 2 pi square root of r to the power of 3 gm. And this is equal to your orbital period. Now, in some problems, they're going to give you an orbital period, and then they're going to ask you to solve for r cubed. Not r cubed, they're going to ask you to solve for r, or the radius of your orbit. All you have to do is a little bit of algebra, manipulate this to isolate your radius variable. And actually, I'll show you how to do that. You can write down, so you can, here, let's erase all the previous work because we're already done. This is the orbital period formula. And if you want to isolate r, divide 2 pi on both sides to get the square root of r cubed over gm. Square both sides, so you get t squared over 4 pi squared is equal to r cubed gm. Multiply gm on both sides, so you get t squared times gm over 4 pi squared is equal to r cubed, and you can cube root both sides. So t squared gm over 4 pi squared is equal to r, or your orbital radius. So just a little bit of algebra could help you solve for any of the variables inside of the orbital period formula. So as always, if you have any questions, put it down in the comment section. If you found this video helpful, consider leaving a like and subscribing. Thanks for watching.